Respected teachers, audience, and authors, Assalamu alaikum and a very good noon. I'm Tanjid Ahmed, third year undergraduate student from Chittagong University of Engineering Technology, Chattanooga, Bangladesh. My paper ID is 054. My presentation topic is any approach to solve job sequencing problem using dynamic programming with reduced time complexity. Here is the table of content. Introduction. Job sequencing problem with deadline is a popular algorithm to find the sequence of jobs to optimize maximum profit. Normally, jobs are given a deadline and profit. If the job is finished before the deadline, the profit is achieved. So every job takes a single time. So the minimum possible deadline for a job is one. So I have to find a maximum profit if only one job can be scheduled at a time. So means the job sequencing problem is a problem where there is a there's a given some jobs or every job which there has a some deadline and profit. If the job can be done within the deadline, the profit is achieved. If the within the deadline the job can't done, then the profit is can't achieve. By this process, we have to find the maximum profit in the sequence of jobs in which, by doing these jobs, we get the maximum profit. In the classical greedy algorithm, they have to sort the jobs according to profit first. Then they have to sequence jobs. Then they use short slots, some slots for maximum according to maximum deadline, and they put the jobs in the slots. By this first they complete the procedure by checking the deadline and putting the jobs in the slots in the class algorithm. In our proposed algorithm, we need not sort the jobs. Using the dynamic programming tabulation method, this algorithm reduce this time complexity for sorting. So we find a new approach to solve the job sequencing problem using dynamic programming with reduced time complexity. Here's the motivation and contribution. The classical algorithm, which is used to solve job sequencing problem with deadline, needs exponential time and a big n square. But because they have to use shortening algorithm, and they have to use all the jobs again and again to fill up the slots for get the maximum profit and the maximum profit sequence, and they use a greedy technique. To reduce the complexity of this classical algorithm, we nullify the sorting algorithm using dynamic programming approach in the proposed algorithm. And in our algorithm, the time complexity reduced to big mn, where m is the maximum deadline and the number of jobs, where no sorting algorithm needed. We have proposed a complete new approach to solve the job sequencing problem with reduced time complexity, which have opened a new scope for further research and improvement. How to use the dynamic program tabulation method, where in all steps total profit is memorized in the first column of the table. This is finding median profit and the sequence of the job. To obtain median profit, the algorithm gives the sequence of jobs for a specific profit or near a specific profit. I had the some related works. Had two related works. First, an improved approximate algorithm for the ancient Syrian problem deadlines. In this paper, aim is to aim the paper aim is to develop an improved polynomial time approximation algorithm. The means FTS algorithm, which time complexity is NSKB, which is nearly the classical algorithm, and the space complexity NSKB, which is omega NSKB, which is greater than the classical algorithm. In the second paper, first approximation algorithm for job sequencing with deadlines in discrete mathematics, applied mathematics. In this with deadlines. In this algorithm, in this proposed method, in this paper, they are used. They solve the job sequencing problem. Here, there's a binding and other properties. There's penalties of delayed jobs, and they have proposed a range of bound method and the complexity, time complexity, and scale log n plus NSKB, which is greater than the class logarithm complexity, and also its space complexity NSKB, which is greater than the class logarithm. Both are greater than the class logarithm. Here, overview of the proposed algorithm. Here given some jobs, job idea 1 2 3 4 5. There are 5 jobs. In the first jobs, deadline is 2 and profit 100. If we complete the jobs within the deadline 2, then we can get profit 100, other is not. This procedure this happen for every jobs. So we have to find the sequence of jobs in which sequence we have to do that we get the maximum profit. Here the process, the initial steps is given. First step, we'll put all the in the first row as 0. Second, then we'll go to the second row. In the second row, we'll consider three conditions. First, within the deadline. Here in the first job, you can see that for first job, the deadline 2. So we'll consider we'll traverse from last to first and we'll consider within the deadline only the first condition. The deadline 2, so we'll do the deadline only 2 to 1, 2 to 1. So we'll condition the deadlines, which is within the deadline. So 2 and 1 are within the deadline too. So the condition 2 and 1, first condition fulfill. Then we have to put the job on. Can I put it? So that we have to consider three conditions. The first condition fulfill, and then we will check if the profit, the first job profit 100 is greater than any of the jobs. Which jobs, which from which jobs it is greater than the profit. Here for Here we get two jobs in deadline. Within the deadline, there are two jobs. Job ID 0 and 0, which property is 0. So it is greater than two jobs, and third. So there we can't. With that, now to check the third condition, we get the point, and from last to first traversing, we put the job here. So this put within the deadline, and the profit is bigger than this. So we'll get a put there. Here in this field will fulfill the field by job ID, which ID is proper to place will place this, and this first column will show the only the maximum this summation of the profits. Has to relation. Here for job ID 2, we can see that for job ID two, we have to put over two. First, we'll see the deadline one. So we have to consider one within one, just only one deadline, because there is only on the. We will consider just one because there is one. So deadline one, so we have to consider one deadline, and we'll consider the first condition fulfilled. Then second condition we'll check is this profit is maximum greater than this previous profit. Yes, for jobs profit is 0. So I had the job is 90. So it is getting this. So I'll put this here. So put this here. Now the job 2. The job 2 ID can be done. So that this is optimal solution of this row, and each row it got to give the optimal solution. And there's 3. Third step, we'll find the we can see the deadline 2. So we'll consider 2 and 1 is possible solution possible, and then we'll the first condition maintains the second condition, which jobs are which field jobs are less than that, profit is less than that. We'll replace this. Here 27 profit 3, and first job profit 100, and second job profit 19. So this field profit is less than 3, so we'll replace it by 3. That's it. So this is the optimal solution for this row, and the maximum profit is from till this row is 127. Next, the profit one. So we'll consider the first and second, third core solution, and all the fill within a deadline, and the profit is within a deadline. And the second solution, the condition if the profit is greater than the previous job's profit. Previous jobs is 3 and 3.27, but it is 25 is less than that, but it is greater than that, so we'll not replace it because it is less than that. If it is greater than that, I will replace it. So it got violating the second condition. So replace the we don't replace the these jobs. We'll remain it as it. That's it. And the last position is last job is 5, and the deadline is 3. So the first condition is that it is preferable deadline 3 to 1. That's it. The second condition, which is the profit is less than that. There are only one profit is less than that. This is only 3. Only this field is this 0 profit is greater than this 15 is greater than 0. So the profit of 0's id job is 0, so it is greater than that, so we can replace it. Otherwise the 1 is 100, and the 3 is 24 27 is greater than that. So the first condition piloting, so that we will put this job here. The third, because the three condition within the jobs and get the maximum profit, and all the job profit it is a maximum. So the three condition fulfilled by this field, so replace it by the id 5. That's it. So we get this equation 3 1 5, which is the sequence to obtain the maximum profit, and this is the maximum profit 142. By this process we can get by using in the columns rows as a job id, and the columns as a deadline. This is the maximum deadline. We get the by using this in the last row we get the maximum job profit, and the sequence in which we have to done the jobs to get the maximum profit. And we can't do for achieve maximum profit, we can't do the jobs 2 and 4. We have to have a 24 job, and have to done jobs first 3, and then say 1 then 5. By this process we by completing the jobs we get the maximum profit on 42. Here's the proposed methodology. Here first we start and read the jobs and take a table where we can see that previously we see that in the first we see that we saw that in the column first deadline row reverse job ID, an initial row at 0, go next row and fill present row as previous row, and search the column to first to find the row's minimum job profit. If the row's minimum job profit is fulfilled, then log this minimum profit box and put the job ID in this box. And no, then sum all the profit of this row and store it in the initial column. By all this row it's traversed, not traversed, then go to the next row and fill the present row as previous row, continuing the process. Otherwise, print the last stress PPI FIR, where fast value is the maximum profit and all the sequence to is this and I had a different flowchart and had the algorithm. Here algorithm first we read the jobs and take an array to and you'll take an array, set an array which is indicating the jobs. That's it. And the maximum deadline here will be check when inputting data. Then we'll get the maximum deadline and put it to M, and we'll take the array and it is 0, with number of n number of rows, n plus one number of rows, m number one plus number of columns, where m is the deadline is jobs. At first, here we use two loops. Here first we'll traverse all the jobs for this loop, and here we'll traverse all the deadlines from last to first. Here S is for the summation of the rows, and that is for checking the for minimum job profit, and this log for log. Here there's this is log from last to first for each row. For each job from last to first row column will search is if the three conditions fulfilled. If the three conditions fulfilled, the first deadline is within the deadline, then it is within the profit, and then it is and replace the minimum job profit. These three conditions fulfilled, then we replace the log this field, and other are all and all else otherwise every other position field will be same as well. And after completing for hereafter traversing over all row, we'll just replace the present row as previous row. We'll replace the we'll put the job in the appropriate position. Now by this process in the first row we'll put the summation of this rows job profits, and here we can print the last row which is maximum which is a sequence to achieve maximum profit, and this is the maximum profit. That's it. Here are the estimate results. Here you can say that for number of job for number of jobs and maximum rating 2, number of jobs 4 and maximum 2. The agent time of the proposal algorithm is 9.13. For agent time of the class algorithm is 1048.67. So it is clear so that so you can see clearly that the agent time of the class algorithm is less than the class algorithm. Agent time of the proposal algorithm is less than the class algorithm for 5 jobs and 3 deadlines. The agent time of the proposal algorithm is 952.35. For agent time of the class algorithm is 999.95. As well, say for 6 jobs and 4 deadline, its deadline 9 over the center 993.13, and over the class algorithm 993.956, and the number of jobs for 7 for example 4. The agent time for the proposal algorithm is 1422.20 1420.4 and microsecond, and for agent time for the class algorithm is 1556.55. As a graphical representation from, we can see that the blue columns shows the classical algorithm, and the red column indicate the new algorithm. So the new algorithm is less than the classical algorithm in each column, and for each pair of column. And the next graph is a line graph which indicate that in the blue line is class for classical algorithm, the red line is for new algorithm. The new algorithm is less than is down from the classical algorithm, class the upper end than the new algorithm. So that you can see that easily the new algorithm is time is less than the classic algorithm. Here the comparison time complete of the classic algorithm is n square, because they are have to short the jobs and traverse all the jobs and put the jobs in the slots. But in our purpose algorithm, best case, best case, worst case, complete mn. This you can see that best case omega of mn, and without sorting, no sorting needed, and average case theta of n, and worst case omega of n, then no sorting is needed. Here always have to traverse the two-dimensional array so that the complete diamond any number of jobs, and I mean deadline x and deadline space complete is OMN because already in 2D array. Complete analysis, we can see that the in complete analysis the overall comparison with the previous classical algorithms, we can see that in the best case for classical algorithm, best episode case is n square minus consecutive n, For paper 1, complete n square log n plus n square b, which is greater than the class logarithm, and for average case n square plus n log n plus n square b, which is greater than the class logarithm also, and is also greater than class logarithm for average case n square plus n log n plus n square b. For space complete n square. For paper 2, this paper 2 for all the for s square complete n square b, which is greater than the class logarithm, and for space complete n square b, which is greater than the class logarithm, and paper 3 also greater than the class logarithm, and our proposed algorithm is less than the class logarithm complexity because mn, and the number of jobs and deadline without sharding all are mn, and the space complexity mn because of using 2D array. Conclusion. Our primary focus was to find a new approach to reduce the time complexity of job sinks in problem deadline from the existing algorithms. Our was independent of using dynamic program tabulation method because our algorithm is always using an optimal solution in each step, and always give the correct solution because each step is the solution is optimal. After comparison of our proposed algorithm approach with the existing algorithm, we saw that our proposed algorithm has an upper hand for the obtaining solution previously and reducing computational time. Our place near and all is optimal. Feature recommendation. Because of using 2D array, the space complexity of proposed algorithm is increased to big of mn. Feature recommendation is to further research to reduce the space complexity of the proposed method. As in future, we'll try to reduce the complexity of the time complexity of the algorithm OMN to OMN less than OMN. There are some references. Thanks for your sharing. Any questions? Thank you.